Hello, and thank you for joining me on this gentle journey. Tonight, we drift into the quiet African wetlands, where the Shoebill Stork stands motionless in shallow, mist-covered water. In this humid stillness, time feels stretched and slowed, as if the swamp itself is holding its breath. The shoebill becomes part of the landscape, silent, patient, and unwavering, waiting for the smallest ripple beneath the surface to break the calm. Let your mind settle into this slow, watery world where even movement feels rare and meaningful. If you enjoy this relaxing moment, please consider liking, subscribing, or sharing your thoughts below. But for now, simply breathe and relax. Let's begin. In the heart of Central and East Africa, vast wetlands stretch outward like a breathing memory of ancient landscapes. Water spreads without urgency, dissolving into shallow floodplains, tangled marshes, and dense papyrus corridors where land and liquid lose their boundaries. It is a world defined not by sharp edges, but by gradual transitions, where everything appears to be in the process of becoming something else, yet never quite arriving. The air here is heavy, saturated with moisture that clings to skin and feather alike. Heat rises slowly from the water's surface, distorting light into wavering sheets that blur distance and soften form. Sound behaves differently in this environment. It does not travel cleanly. Instead, it folds into vegetation, absorbed by reeds and floating mats of plant life that dampen even the faintest disturbances. What remains is a kind of living silence, not empty, but full of restrained presence. Within this still, humid expanse, life moves according to a rhythm that feels almost geological in its patience. Fish drift through submerged roots, reptiles slide beneath murky surfaces, and unseen insects trace invisible paths through the air. Every movement is deliberate, often hidden, as if the swamp itself discourages haste. Nothing here is wasted. Energy is conserved, released only when necessary, then absorbed again by the slow cycle of water and decay. Among these layered ecosystems stands one of the swamp's most remarkable inhabitants, the Shoebill Stork. At first glance, it appears almost unreal, as though carved from the same reeds and shadows that surround it. Tall and motionless, it holds its position in the waterlogged terrain with an unnatural stillness. Its presence does not disrupt the environment. Instead, it merges with it, becoming another vertical shape among countless stalks of papyrus. Time behaves differently around such a creature. Hours pass without visible change. The shoebill does not pace or shift in search of advantage. It waits. And in this waiting, it reflects the nature of the swamp itself, where survival is not driven by urgency, but by endurance. The line between organism and environment begins to blur. It is difficult to determine whether the bird is standing in the swamp or emerging from it. This ecosystem rewards patience in ways that more volatile environments do not. Sudden movement can mean exposure. A ripple on the water may reveal presence to unseen eyes. As a result, stillness becomes a form of intelligence, a strategy embedded not only in behavior, but in the very logic of survival. The swamp does not punish inactivity. It punishes imbalance, excess, and unnecessary motion. Beneath the surface, the world continues its hidden negotiations. Nutrients circulate through slow decay. Plants rise and collapse in seasonal cycles. Floodwaters expand and retreat with quiet authority, reshaping the landscape without warning. Each change is gradual, yet irreversible, like breath taken over centuries. Within this shifting foundation life learns to adapt not by resisting change, but by aligning with it. The shoebill stork exists fully within this philosophy of restraint. It does not attempt to dominate the swamp, nor escape it. Instead, it participates in its stillness, standing as both observer and component of the same system. The boundary between predator and environment becomes increasingly indistinct the longer it remains unmoving. In this place, silence is not absence. It is structure. It is information carried through absence of noise. The swamp communicates in subtle disturbances, in the faint ripple of water or the bending of reed tips under unseen pressure. To exist here is to understand that every still moment holds potential meaning, waiting to be interpreted. And so, the wetlands of Central Africa continue their quiet existence, vast and unhurried, shaping all that lives within them through the simplest and most powerful force of all: time without urgency. Within the quiet architecture of the swamp, where visibility fades into green shadow and water carries more secrets than clarity, the shoebill stork's most defining feature emerges as something almost architectural in itself. Its massive shoe-shaped bill dominates its profile, not as decoration or exaggeration, but as a highly specialized instrument shaped by long evolutionary pressure. This beak is not merely large in proportion to the bird's body. It is engineered with a specific functional logic that reflects the demands of its environment. In the dim, sediment-rich waters of Central African wetlands, prey rarely presents itself in clean, predictable motion. Instead, it hides beneath floating vegetation, burrows into mud, or drifts just out of sight in oxygen-depleted channels where visibility is reduced to faint impressions of movement. In such conditions, precision becomes more important than speed alone. The structure of the shoebill's bill allows it to act as both a gripping mechanism and a force amplifier. Its broad surface area enables it to envelop prey in a single decisive motion, while its sharp, slightly hooked edges help secure slippery bodies that would otherwise escape into the murk. When it closes, the force is concentrated with enough power to immobilize fish that struggle violently within its grasp. Yet what makes this adaptation even more remarkable is not only its strength, but its sensitivity. The bill is filled with nerve endings capable of detecting subtle vibrations in the water. These micro-movements, often invisible to the eye, become critical signals in an environment where sight alone is insufficient. A faint tremor beneath a layer of silt may indicate the presence of a lungfish or eel shifting position just below the surface. The beak becomes an extension of perception, translating physical disturbance into actionable awareness. In this way, the shoebill does not simply hunt with its eyes. It hunts with its entire frontal anatomy, where vision, touch, and mechanical force converge into a single integrated system. The swamp demands this level of integration. No single sense is reliable on its own. Water absorbs light, vegetation fragments sound, sediment distorts movement. Only through layered perception can a predator interpret what lies beneath. The evolutionary refinement of this structure did not happen in isolation. It emerged over generations of interaction between predator and environment, shaped by the constant challenge of extracting energy from a habitat that conceals as much as it reveals. Prey in these waters is often resilient, adapted to low oxygen conditions, and capable of sudden bursts of escape. The shoebill's response is not pursuit, but interception. It waits until probability aligns with certainty, then commits to a single, irreversible motion. There is also a quiet efficiency embedded within the beak's design. Unlike many predators that rely on repeated strikes or prolonged struggle, the shoebill's method emphasizes containment over contest. Once prey is secured, escape becomes increasingly unlikely. The mechanics of the bill reduce the need for extended exertion, conserving energy in an ecosystem where successful captures may be separated by long periods of inactivity. Even the visual presence of the beak contributes to its function. In the swamp's fractured light, its silhouette resembles an object both ancient and deliberate, something closer to carved wood or hardened sediment than living tissue. This ambiguity may play a subtle role in how prey perceives it, especially in environments where recognition is distorted by water and reflection. The shoebill stork, standing motionless among reeds, carries this evolutionary tool as both identity and function. It is not separate from the bird, nor merely attached to it. It is an extension of its survival logic, shaped by countless interactions between still water, hidden movement, and the necessity of precise action in an environment that rarely offers second chances. Within this system, the beak is not just a weapon. It is a translation device between the visible and the hidden, the sensed and the unknown, allowing the shoebill to operate in a world where clarity is always partial and success depends on interpreting what others cannot see. A single shoebill stork standing in the wetlands can appear indistinguishable from the surrounding vegetation, not because it hides in the traditional sense, but because it reduces itself to near total stillness for extended periods. In the shallow floodplains of Central and East Africa, this behavior defines its hunting identity, transforming it into a vertical extension of reeds, papyrus stems, and shadowed water edges. Extended immobility is central to its survival strategy. Rather than actively searching for prey, the shoebill positions itself in areas where aquatic life is likely to pass through narrow channels or oxygen-poor pools. Once settled, it remains in place for long durations, maintaining a posture that minimizes detectable movement. Even subtle shifts in weight distribution are controlled with remarkable restraint, ensuring that no unnecessary disturbance travels through the water. Stillness in this environment provides a significant functional advantage. Many aquatic species in swamp systems are highly sensitive to vibration and surface disturbance. A single ripple can signal danger or trigger evasive behavior. By eliminating almost all self-generated motion, the shoebill reduces the likelihood of alerting potential prey before striking distance is achieved. This restraint is not passive waiting, but a calibrated form of environmental integration. Attention remains sharply focused during these extended intervals. The bird's gaze is typically fixed on a confined section of water or floating vegetation, where faint irregularities may indicate hidden movement below the surface. Instead of scanning broadly, it narrows its observational field, increasing the likelihood of detecting subtle changes in light reflection or sediment displacement. This concentrated attention allows it to interpret minimal visual input with high precision. Micro adjustments in posture occur infrequently and with careful control. When they do happen, they are often linked to maintaining balance rather than signaling intent. The shoebill's long legs are positioned to distribute weight evenly across unstable ground, reducing the risk of sinking into soft substrate. This stability supports its ability to remain stationary without fatigue, even when environmental conditions shift slightly with water movement or wind through surrounding vegetation. Environmental interaction plays a critical role in enhancing its concealment. Reeds and papyrus grow densely in these wetlands, creating vertical patterns that obscure outlines and break up shapes. The shoebill's tall, upright form blends into these natural structures, especially when viewed through shimmering water surfaces or partial shade. Light distortion caused by humidity and heat further reduces clarity, allowing the bird to remain visually unremarkable despite its size. Competition and ecological pressure also reinforce this behavior. Other predators in the same habitat may rely on more active hunting strategies, but movement increases exposure in an ecosystem where visibility is unpredictable. By minimizing motion, the shoebill reduces encounters with both competitors and potential threats, positioning itself within a narrower ecological niche defined by patience and precision. Energy conservation is another important outcome of this approach. Extended inactivity significantly lowers metabolic demand, which is essential in environments where successful hunts may be infrequent and dependent on seasonal flooding patterns. By reducing unnecessary exertion, the bird maintains readiness for sudden action without depleting its reserves. This balance between inactivity and readiness is a defining feature of its survival strategy. When prey finally enters range, the transition from immobility to action is abrupt and highly coordinated. However, this moment of acceleration is only possible because of the long preparatory interval that precedes it. Every second of still positioning contributes to the likelihood of success, building a framework of timing rather than pursuit. Within the broader swamp ecosystem, this method represents a distinct evolutionary path. Instead of adapting towards speed or endurance in motion, the shoebill has refined the ability to remain stationary without loss of awareness or readiness. In doing so, it occupies a role shaped not by constant activity, but by controlled restraint aligned with environmental rhythm. A motionless figure among the reeds can hold its position for extended periods. But within the shoebill stork, this restraint is paired with an ability for immediate, high-speed action when prey enters striking range. In the swamp environments of Central and East Africa, where aquatic life often appears only briefly at the surface, timing becomes the decisive factor between success and failure. Explosive movement defines the transition from still posture to capture. The shoebill relies on powerful neck musculature that functions like a loaded spring held in suspension. When triggered, this system releases stored mechanical force in a fraction of a moment, propelling the bill forward with controlled acceleration. The speed of this motion is not random. It is the result of precise neuromuscular coordination shaped by repeated evolutionary pressure in environments where prey visibility is fleeting. Prey in these wetlands rarely remains exposed for long. Lungfish, catfish, and eels often surface only briefly to breathe or reposition before disappearing into murky water or submerged vegetation. This narrow window of opportunity demands immediate response. The shoebill does not pursue over distance. Instead, it intercepts movement at the exact point of emergence, relying on anticipation built from prolonged observation. Accuracy is essential during this strike phase. The bill must close at the precise location where the prey is located, despite distortion caused by water refraction and sediment suspension. Depth perception and motion tracking work together to compensate for visual uncertainty. The forward-facing eye placement supports binocular coordination, allowing the bird to calculate distance even when only partial outlines of prey are visible beneath the surface. Impact force is another critical element of the strike. Upon contact, the bill closes rapidly with enough pressure to immobilize or injure aquatic animals that may attempt sudden escape. This mechanical strength is particularly important when dealing with species adapted to swamp survival, many of which possess flexible bodies or the ability to burrow into soft sediment within seconds. Environmental conditions influence the effectiveness of each strike. Dense vegetation can obscure both predator and prey, while floating plant matter may interfere with direct line of movement. Despite these obstacles, the shoebill adapts by selecting positions that maximize visibility into likely travel corridors used by aquatic organisms. These include narrow channels between papyrus stands and shallow basins where oxygen levels are lower, forcing fish to surface more frequently. The shift from stillness to action is not only physical, but also neurological. Sensory input gathered during long observation periods is rapidly integrated, allowing immediate decision-making without hesitation. This rapid response system reduces delay between detection and engagement, increasing the probability of successful capture during brief exposure moments. Once prey is secured, the motion does not continue beyond what is necessary. The bird stabilizes its stance again, returning to immobility after the strike concludes. This return to baseline behavior is essential for conserving energy and preparing for the next opportunity, which may occur after extended waiting periods. The cycle of extended observation followed by sudden motion defines its hunting rhythm. Across swamp ecosystems, this method of predation contrasts sharply with species that rely on sustained pursuit or repeated attempts. Instead, the shoebill depends on precision timing, biomechanical power, and environmental awareness, concentrated into a single decisive moment. Each strike represents the culmination of extended environmental monitoring, compressed into an instant of action. Within this framework, stillness and rapid motion are not separate behaviors, but interconnected components of a unified survival strategy shaped by wetlands, where opportunity is brief and certainty is rare. Stretching across Central and East Africa, vast wetland systems form some of the most productive freshwater environments on the planet, shaped by seasonal rainfall, river overflow, and slow-moving flood dynamics. These landscapes shift constantly between submerged plains and emergent grasslands, creating a mosaic of habitats that support an extraordinary range of life forms adapted to fluctuating water levels. Flood pulses define the structure of these ecosystems. During rainy seasons, rivers expand beyond their channels and spread across low-lying terrain, carrying nutrients that enrich the soil and stimulate rapid plant growth. As water recedes, it leaves behind isolated pools and channels that concentrate aquatic organisms, increasing interactions between predator and prey. This repeating cycle of expansion and contraction governs nearly every biological rhythm within the swamp. Papyrus stands and reed beds dominate large portions of these wetlands, forming dense vertical corridors that restrict movement and visibility. These plant structures provide shelter for fish, amphibians, reptiles, and invertebrates, while also serving as hunting grounds for larger predators. Beneath the surface, tangled root systems stabilize sediment and create complex microhabitats where oxygen levels, temperature, and nutrient availability can vary dramatically over short distances. Within this layered environment, food webs operate with high interdependence. Small fish feed on plankton and detritus suspended in the water column, while larger aquatic species regulate their populations. Birds, reptiles, and mammals interact with these networks at different levels, relying on seasonal abundance to sustain reproduction and growth. Energy transfer is closely tied to water movement, which redistributes organic material and supports productivity across the system. The shoebill stork occupies a specialized ecological niche within this framework. It relies heavily on habitats where water is shallow, oxygen levels are reduced, and vegetation density limits escape routes for prey. These conditions are particularly favorable for species such as lungfish, catfish, and eels, which form a significant portion of its diet. The bird's presence is closely linked to the availability of these prey-rich zones, making it highly dependent on local hydrological conditions. Seasonal variation plays a critical role in shaping feeding opportunities. When water levels are high, prey disperses across broader areas, making encounters less frequent. As levels drop, aquatic organisms become concentrated in shrinking pools and channels, increasing hunting efficiency for predators that can exploit confined spaces. The shoebill benefits most during these transitional periods, when movement patterns of aquatic life become more predictable. Environmental sensitivity is a defining feature of this ecosystem. Small changes in rainfall patterns, river flow, or vegetation growth can alter habitat structure significantly. Prolonged drought conditions may reduce breeding success for aquatic species, while excessive flooding can disrupt nesting sites and feeding grounds. These fluctuations require constant adaptation from all organisms within the system, including top-level predators. Competition among species adds another layer of ecological interaction. Fish-eating birds such as herons, kingfishers, and ibises share overlapping diets, though they often differ in hunting technique and preferred microhabitats. The shoebill distinguishes itself through its preference for dense, shallow wetlands, where visibility is low and prey must surface frequently to breathe or reposition. Human influence has also become increasingly relevant in some regions of these wetlands. Agricultural expansion, drainage projects, and water diversion can reduce available habitat and fragment continuous swamp systems into smaller, isolated patches. These changes affect water quality, prey distribution, and vegetation structure, all of which influence the stability of species dependent on intact wetland environments. Despite these pressures, swamp ecosystems remain among the most biologically diverse freshwater habitats on Earth. Their complexity arises not from uniform conditions, but from constant variation in depth, flow, and vegetation density. This variability creates opportunities for specialized species to evolve highly specific survival strategies. Within this shifting landscape, the shoebill stork persists as a highly adapted predator, shaped by the rhythms of water movement and the structural complexity of papyrus-filled wetlands, where every change in water level reshapes the balance of life above and below the surface. Across the dim waterways of Central African wetlands, visibility often collapses into layers of distortion, where suspended sediment, floating vegetation, and shifting reflections reshape every attempt at clear sight. In this environment, the shoebill stork relies on a visual system adapted to extracting meaningful information from highly obscured surroundings. where direct lines of view are frequently interrupted by plant growth and murky water surfaces. Forward-facing eyes provide the foundation of its visual capability, enabling a degree of binocular overlap that supports depth perception. This arrangement allows the bird to estimate distance when targeting prey that is partially submerged or concealed beneath floating mats of vegetation. In habitats where objects are rarely fully visible, the ability to judge spatial relationships becomes essential for successful hunting. Focus behavior plays an important role in how the shoebill interprets its surroundings. Rather than continuously scanning in rapid motion, it often fixes its gaze on a restricted area of water for extended periods. This sustained attention reduces unnecessary visual disruption and allows subtle changes in the environment to become more noticeable, such as faint ripples or slight displacement of floating debris that may indicate movement below the surface. Water conditions in swamp systems introduce significant optical challenges. Sediment reduces clarity, while sunlight filtering through dense vegetation creates uneven patterns of brightness and shadow. These variations can obscure the true position of moving organisms, making visual interpretation more complex. The shoebill compensates by relying on contrast shifts and movement detection rather than clear object definition. Head stability is another important factor in maintaining effective vision. By minimizing unnecessary head movement, the bird reduces visual noise caused by self-induced motion. This stability supports more accurate interpretation of subtle environmental cues, especially when tracking potential prey that may only appear briefly before disappearing into deeper water or dense plant cover. Prey detection in such environments depends heavily on recognizing indirect indicators rather than direct sight. Small disturbances in the water surface, slight oscillations in vegetation, or sudden changes in reflection patterns can signal the presence of fish or amphibians beneath the surface. These cues require careful interpretation, as similar disturbances can also result from wind, water flow, or non-biological movement. The shoebill's visual system is supported by a relatively large eye structure compared to many other wading birds, enhancing light capture in shaded wetland conditions. This adaptation improves performance in low-contrast environments, where reduced illumination can limit the ability to distinguish movement. Even under such conditions, the bird maintains the ability to detect relevant changes within its immediate field of view. Spatial awareness in swamp habitats is not solely dependent on vision alone, but is reinforced through integration with other sensory inputs. Vibrations transmitted through water and subtle pressure changes can complement visual information, creating a more complete understanding of nearby activity. This multi-layered perception is particularly useful in environments where visual clarity is inconsistent. Environmental variability further shapes how visual strategies are applied. Shifting water levels can alter the distance between predator and prey, while changing vegetation density can restrict or expand lines of sight. As a result, the shoebill must continuously adapt its visual focus depending on local conditions, selecting positions that maximize the likelihood of detecting movement within confined corridors of visibility. Unlike predators that rely on rapid pursuit or broad scanning behavior, the shoebill's approach emphasizes sustained observation of limited zones. This method reduces unnecessary visual distraction and increases the probability of noticing subtle irregularities within a complex background. Over time, This creates a hunting style defined by patience in observation, combined with readiness for immediate action when conditions align. Within the layered optical environment of swamp ecosystems, vision becomes less about clarity and more about interpretation. The Shoebill Stork operates within this framework, using focused perception to extract meaning from partial information, allowing it to function effectively in waters where visibility is constantly shaped by movement, sediment, and light. Deep within the swamp corridors of Central and East Africa, where feeding opportunities can be unpredictable and widely spaced, the Shoebill Stork relies on a physiological strategy centered on extreme energy efficiency. Rather than maintaining constant activity, its survival depends on reducing energy expenditure to match the irregular availability of prey across fluctuating wetland conditions. Metabolic regulation forms the foundation of this adaptation. By remaining motionless for extended periods, the shoebill significantly lowers its overall energy consumption. Muscle activity is minimized, and unnecessary movements are avoided whenever possible. This reduction in physical exertion allows the bird to conserve internal reserves, which become critical during long intervals between successful hunts. Energy balance in swamp environments is closely tied to ecological timing. Seasonal flooding determines the distribution and abundance of aquatic organisms, which in turn affects feeding success. During periods when water spreads widely across floodplains, prey disperses and becomes harder to locate. As waters recede, fish and amphibians concentrate in smaller pools, increasing hunting efficiency. The shoebill's metabolic strategy is aligned with these cycles, allowing it to endure periods of low intake without compromising readiness. Physiological stability is reinforced by its ability to remain upright and stationary without frequent muscular adjustments. The skeletal structure of long legs supports body weight efficiently, distributing load in a way that reduces fatigue during prolonged standing. This structural adaptation allows the bird to maintain position for hours while waiting for suitable conditions to strike. Thermoregulation also plays a role in its energy management. Wetland habitats often experience variable environmental conditions influenced by water coverage, vegetation density, and solar exposure. By limiting movement and selecting shaded or partially covered areas, the shoebill reduces unnecessary heat gain and avoids excessive energy loss associated with thermoregulatory adjustments. This passive regulation supports long-duration positioning in exposed or semi-exposed habitats. Digestive efficiency further contributes to its survival strategy. When prey is captured, it is consumed in a manner that maximizes nutrient intake relative to energy expenditure during hunting. Large prey items such as lungfish or catfish provide substantial caloric value, supporting extended periods of inactivity following successful feeding events. This high reward-to-effort ratio is essential in environments where each capture may be separated by significant time gaps. Neurological control mechanisms help regulate the transition between inactivity and sudden movement. Sensory systems remain alert during long stationary phases, continuously processing environmental input for signs of prey activity. Despite outward stillness, internal responsiveness remains active, allowing immediate engagement when conditions become favorable. This balance between restraint and readiness is central to its hunting efficiency. Comparative ecological pressures in swamp habitats reinforce this low-energy strategy. Many competing species rely on frequent movement to forage or hunt, which increases energy demand and exposure. In contrast, the shoebill's approach reduces both energy use and visibility to potential threats. This dual advantage enhances its ability to persist in habitats where resources are unevenly distributed. Long-term survival in such ecosystems requires alignment with environmental rhythm rather than resistance to it. Flood cycles, prey migrations, and vegetation changes all influence energy availability. By minimizing expenditure during inactive phases, the shoebill effectively synchronizes its biological demands with external conditions. Even minor adjustments in posture are carefully moderated to avoid unnecessary energy loss. Shifts in weight distribution are subtle and infrequent, maintaining stability without introducing fatigue. This controlled stillness is not passive inactivity, but a highly regulated state of readiness maintained through physiological balance. Within this framework, survival is not determined by constant effort, but by efficient allocation of energy over time. The shoebill stork exemplifies this principle, maintaining a system where low metabolic output and sudden high-intensity action coexist within a finely tuned ecological strategy shaped by the unpredictable rhythms of swamp environments. Beneath the tangled surface of Central African swamps, a diverse community of aquatic organisms thrives in environments shaped by fluctuating oxygen levels, seasonal flooding, and dense vegetation. Among the most important prey species for the shoebill stork are lungfish, catfish, eels, and a range of amphibians that have evolved specialized adaptations for survival in low-oxygen waters. Lungfish occupy a particularly significant role in this ecosystem. These ancient fish possess the ability to survive extended periods in oxygen-poor conditions by entering a state of reduced metabolic activity, often burrowing into mud during dry phases. When water levels rise again, they re-emerge into active environments where feeding and movement resume. This cyclical behavior makes them both resilient and periodically vulnerable, especially in shallow wetland zones where escape routes are limited. Catfish represent another major component of the shoebill's diet. Many species in these waters are equipped with sensory barbels that allow them to detect food in murky conditions, giving them an advantage in low-visibility environments. However, their reliance on close-range detection also brings them into contact with ambush predators that exploit similar sensory limitations. In narrow channels and shallow basins, their movement patterns often intersect with stationary hunters waiting for passing prey. Eels contribute further complexity to the food web. Their elongated bodies and rapid serpentine motion enable quick escapes through vegetation and sediment. Despite this agility, they are still susceptible to sudden interception when traversing confined waterways. Their tendency to move through predictable routes within swamp networks increases the likelihood of encounters with stationary predators positioned along these corridors. Amphibians, such as frogs and small aquatic species, also form part of the shoebill's dietary range. These organisms often rely on surface activity for breathing and feeding, exposing them intermittently to aerial and wading predators. Their life cycles are closely tied to water availability, with breeding and development stages influenced by seasonal flooding patterns that expand or restrict suitable habitat. The shoebill stork employs a hunting method specifically adapted to these prey behaviors. Rather than chasing moving targets over distance, it positions itself along ecological bottlenecks where aquatic life is likely to pass through confined spaces. These include shallow channels between papyrus stands, receding flood pools, and oxygen-depleted basins where prey density increases as water levels decline. Capture success depends heavily on timing and precision. Prey often appears only briefly at the surface or within striking range before retreating into cover. The shoebill responds by maintaining prolonged observation of these zones, waiting for predictable movement patterns to emerge. Once a target enters range, the bird executes a rapid forward motion, using its powerful bill to secure the animal before escape becomes possible. Handling of captured prey varies depending on size and resistance. Smaller organisms may be swallowed immediately after capture, while larger fish require repeated gripping motions to ensure immobilization. The structure of the bill allows it to maintain a firm hold on slippery or struggling prey, reducing the likelihood of escape during consumption. Swamp prey species have evolved under strong selective pressure from both environmental constraints and predation risk. Many exhibit behaviors designed to minimize exposure, such as nocturnal activity, burrowing, or rapid surface breathing. These adaptations create a constantly shifting balance between concealment and necessity, where survival often depends on brief exposure to risk. Within this system, the shoebill stork functions as a specialized apex predator, adapted to exploit moments of vulnerability in aquatic life cycles. Its hunting strategy aligns with environmental rhythms, targeting periods when prey movement becomes constrained by geography, oxygen availability, or seasonal water concentration. Across the wetland landscape, predator and prey remain tightly interconnected, shaped by the same cycles of flooding and retreat that define the structure of the swamp itself, where every movement through water carries both opportunity and risk. Across remote stretches of Central and East African wetlands, reproductive success for the shoebill stork depends on access to stable, undisturbed terrain that can support large nests within shifting aquatic landscapes. These nesting sites are typically found in secluded swamp regions, where papyrus stands and reed beds provide both structural material and partial concealment from disturbance. Construction of the nest begins with the careful gathering of vegetation from surrounding marshes. Reeds, grasses, and aquatic plants are assembled into a broad platform that floats or rests on slightly elevated ground depending on water levels. This structure must remain stable through seasonal changes, particularly during periods of flooding when water can rise and submerge previously dry nesting areas. Pair bonding in shoebills is generally cooperative during the breeding period. Both adults participate in nest building, incubation, and protection of the developing young. This shared investment increases the likelihood of chick survival in an environment where external conditions can shift rapidly. The breeding cycle is closely synchronized with seasonal water patterns, ensuring that food availability aligns with the energetic demands of chick rearing. Egg incubation requires sustained protection from environmental exposure. The nest is maintained through continuous adjustment of surrounding material to ensure insulation and stability. Temperature regulation is achieved through positioning within shaded or partially sheltered areas of dense vegetation, reducing direct exposure to sun and wind. This environmental buffering is essential for maintaining consistent developmental conditions. Chick development occurs in stages marked by increasing independence and physical growth. In early phases, young shoebills rely entirely on parental feeding, receiving partially regurgitated prey brought from nearby hunting grounds. As they mature, they begin to exhibit stronger coordination and increased awareness of their surroundings, gradually preparing for independent movement within the wetland environment. Survival rates during this stage are influenced heavily by environmental stability. Sudden changes in water levels can flood nesting sites or isolate them from feeding areas, placing significant stress on both adults and offspring. Extended drought conditions can reduce prey availability, increasing competition and reducing feeding frequency. These fluctuations create a narrow margin for successful reproduction. Predation pressure on nests exists, but is relatively limited compared to smaller bird species, primarily due to the remote and concealed nature of shoebill nesting locations. However, vulnerability still arises from environmental exposure rather than direct predation. Instability in water levels remains one of the most significant risks to reproductive success. Nest placement is therefore a critical behavioral decision. Locations are selected based on proximity to reliable feeding zones and relative protection from flooding extremes. Slight variations in elevation or vegetation density can determine whether a nesting site remains viable throughout the breeding cycle. This dependence on microhabitat stability makes reproductive success highly sensitive to ecological variation. Chick growth is supported by a steady supply of high-protein prey delivered by both parents. Feeding frequency is adjusted according to availability within nearby wetlands, with adults traveling between hunting grounds and nesting sites in repeated cycles. This movement creates a connection between reproductive sites and broader ecosystem productivity, linking breeding success directly to wetland health. As juveniles develop, they gradually begin to explore the surrounding environment, stepping away from the nest area under supervision. Early movements are limited and cautious, reflecting both physical development and environmental awareness. Over time, coordination improves, and young birds begin to mirror the hunting posture and stillness behavior of adults. Within this reproductive framework, isolation serves a protective function rather than a limitation. Remote nesting sites reduce disturbance and increase stability, allowing young shoebills to develop within environments shaped primarily by natural cycles rather than external interference. Across these floating worlds of reeds, water, and shifting ground, the continuation of the species depends on careful alignment between biological timing and wetland dynamics, where each successful nesting cycle represents a precise balance between environmental stability and adaptive behavior. Standing motionless among dense stands of papyrus, the shoebill stork presents one of the most distinctive silhouettes in African wetlands, resembling a structure shaped by both biology and environment, rather than a typical avian form. Its tall posture, heavy bill, and minimal movement combine into an image that often appears detached from the surrounding activity of the swamp. Perception of stillness in this species is closely tied to its hunting strategy, where prolonged immobility increases the probability of detecting prey without being detected in return. In shallow floodplains and narrow channels, movement often triggers avoidance responses in aquatic organisms, making restraint a functional advantage rather than a passive trait. The shoebill integrates this behavior into every aspect of its foraging approach. Evolutionary adaptation has refined this reliance on restraint over extended periods. Instead of relying on frequent movement to locate food, the bird positions itself in ecologically productive zones and remains there while monitoring subtle environmental changes. This reduces unnecessary energy expenditure while maximizing opportunities for ambush-based feeding events. The impression of lifelessness often attributed to the shoebill arises from its ability to maintain posture with minimal visible adjustment. However, beneath this external stability lies continuous sensory engagement. Visual tracking remains active, and auditory and vibrational cues are constantly processed to detect disturbances in water or vegetation that may indicate prey activity. In swamp environments, where light is fragmented by vegetation and surface reflections distort perception, immobility enhances detection efficiency. By eliminating self-induced motion, the bird reduces interference in its own sensory field, allowing it to interpret external changes with greater clarity. This balance between still form and active awareness is central to its ecological role. Predatory efficiency in this species depends not on pursuit, but on alignment with environmental rhythms. Fish and amphibians in wetland systems often follow cyclical movement patterns influenced by water levels, oxygen availability, and vegetation density. The shoebill positions itself along these predictable pathways, increasing the likelihood of encounter without active searching. The structural design of its body further supports this strategy. Long legs allow elevation above shallow water, reducing disturbance while maintaining access to submerged prey zones. The neck and bill remain poised for rapid extension when necessary, enabling a transition from immobility to action in a single coordinated movement. Across the broader ecological landscape, this form of hunting contrasts with species that rely on continuous locomotion or group coordination. Instead, the shoebill represents a solitary strategy centered on minimal energy output combined with high-precision response capability. This specialization allows it to occupy ecological niches where patience provides a measurable advantage. Environmental stability plays a significant role in sustaining this behavior. Wetlands with consistent water levels and intact vegetation structure offer optimal conditions for prolonged stationary hunting. When these conditions fluctuate, the effectiveness of this strategy can change, requiring adjustment in positioning or movement range. Human observation of the shoebill often emphasizes its statue-like presence, but this interpretation overlooks the internal complexity of its interaction with the environment. Rather than inactivity, what appears externally as stillness is a continuous state of monitoring, where external inputs are constantly evaluated against potential opportunities for feeding. Subtle sensory cues are continuously integrated, allowing the bird to distinguish meaningful disturbances from background variation within the wetland. This sustained attentiveness ensures that even the briefest emergence of prey does not go unnoticed. Over time, this form of vigilance becomes a defining survival mechanism, linking perception directly to survival outcomes in an ecosystem where opportunity is fleeting and conditions are constantly shifting. Within the wetland ecosystem, this species occupies a role defined by restraint, precision, and environmental awareness. Its survival is tied to its ability to remain positioned within dynamic landscapes without losing responsiveness to sudden change. Even minor shifts in water flow or prey movement can determine feeding success, reinforcing its dependence on acute sensitivity to subtle environmental cues while maintaining complete physical stability. Across Central African swamps, where water, vegetation, and life forms shift in constant variation, the shoebill persists as a highly specialized predator, shaped by conditions that reward endurance over motion and awareness over pursuit. In these wetlands, every change in water level subtly rearranges the availability of food, altering where fish concentrate, where amphibians surface, and where oxygen-poor pockets force aquatic life into tighter, more predictable routes. The shoebill's existence is tightly bound to these shifting patterns, allowing it to occupy feeding zones that many other predators cannot consistently exploit. Its survival is reinforced by an ability to interpret environmental instability as structure rather than chaos. Seasonal flooding does not disrupt its behavior, but instead defines when and where it becomes most effective. As waters expand, it adjusts positioning across broader floodplains. As they recede, it concentrates near narrowing channels where prey density increases. This adaptability ensures that its hunting efficiency remains aligned with the rhythm of the ecosystem rather than resisting it. Even within moments of complete stillness, the bird remains fully engaged with its surroundings, tracking subtle changes in water movement, vegetation sway, and surface disturbance. This continuous awareness allows it to respond instantly when opportunity emerges, converting long periods of observation into decisive action. In this way, the shoebill represents a form of ecological specialization where patience, precision, and environmental alignment define success in one of the most dynamic freshwater systems on Earth. As our journey through the wetlands comes to a close, picture the shoebill standing quietly in fading mist, the water returning to complete stillness around it. There is a deep calm in its world, where patience is everything and silence carries its own quiet strength. Let the gentle sensations of peace and calmness settle through your body and mind. Feel your thoughts slow, your breathing deepen, and your body soften into rest. If you enjoyed this relaxing moment, please consider liking, subscribing, or sharing your thoughts below. You can also turn on the notification so you don't miss any of our future journeys together. But for now, let your body relax, release all tension, and allow your mind to drift gently into rest. Good night and sleep well.